Oakley dokley, guys. Today we are going to be starting chapter 4, and chapter 4 is all about multiplying decimals. Chapter 3 we were adding and subtracting decimals, and now we're going to take it a step further and start multiplying. So as we've started the last few chapters, we're going to be looking at our dancing decimal. As you can see in my notes, the dancing decimal has returned for another appearance. So please make sure to take some strenuous notes so that it makes sense to you, because we're going to be looking at patterns within our decimals using our dancing decimal as a guide. Alright, so the first thing that I want you to remember is that a decimal lives behind all whole numbers. This is important to remember. Decimals live behind all whole numbers. So if it is a whole number, like say 3, and you say, well, there's no decimal in it, you would be wrong. That decimal lives right there. Please keep that in your head. So please create this T-chart that I have here with your multiplication problems. 2 7/100 times 1, 2 7/100 times 10, 2 7/100 times 100, and 2 7/100 times 1,000. We're going to be solving these problems. That multiplying numbers will give a product that is larger than what you started with. Well, as long as both numbers have whole numbers in them. So here, in our T-chart, you'll notice that all of our numbers are whole numbers. Alright, the whole numbers are larger. They're 1 or larger. Okay? So going along, I'm going to solve these. 2 7/100 times 1, we know, because of the identity property, is 2 7/100. Now 2 7/100 times 10, according to my post-it note, I should get a larger number than what I started with. So I can do the problem out and I can solve it using standard algorithm. Or I can just know that if I bump my decimal one place value over, that will give me the proper product. So if I bump my decimal one place value to the right to give me a bigger number, a larger number, that will be my new product, 20 7/10. Following the same pattern, now I have 2 zeros in my 100. My number should still be getting bigger. I'm going to bump my decimal 2 place values to the right, giving me a product of 207. And lastly, the same thing again. Now I have 3 zeros in my problem, so I bump my decimal 3 place values, and now I have a spot without a digit in it, so I can fill it with a 0. Now looking at these problems here, 372 times 1, 372 times 1/10, 372 times 100, 372 times 1,000. Now my first post-it note here said that multiplying numbers that are 1 or larger will give me a larger number than what I started with, or equal. Now that's not the case if our number is smaller than 1. 1/10 is smaller than 1. It is a piece, a part. 1 100th is smaller than 1. It is a piece, it is a part of a whole. 1 1,000th is a part of a whole. It is less than $1 whole. Now if I have a number that is less than 1 when multiplying, then it changes my first post-it note. So if I'm multiplying a number that is 1 or larger, then my product will be equal or larger. Unless one of those numbers is less than a whole number. In that case, our number will be smaller than our product will be formula. 372 times 1, identity property says, stays the same, still 372. 372 times 1/10. Now a tenth is less than a whole number. So I know, according to my notes from earlier, that there's a decimal that lives behind every whole number, and this is a whole number, so I do have a magic decimal there. And I know that I'm going to bump this one place value to the left because this number is less than a whole, so my decimal is going to bump in one place over. Okay? Remember, 1/10 written like this is the same as 1/10. So bumping my decimal behind my whole number one place value to the left gives me a product of 37 2/10. Behind this decimal I have two place values, so I have to bump this one in two places, giving me 3 72 hundredths. And again, after this decimal I have three place values, so I have to bump my invisible decimal three place values to the left. So depending what you're multiplying by will determine what direction your decimal moves. Last problem. Now we're going to be looking at numbers multiplying with exponents. That's not that scary. We've done that before, right? Let's review. Remember that the exponent tells you how many zeros go behind your 1 when we're talking about a base 10. So in this case, I'm going to have a 1 with exactly 0 zeros, because you can see that I have a 0 as my exponent. So a 1 with 0 zeros is just 1 times 7 equals 7. 10 to the first power is a 1 with 1 0, which is 10 times 7 gives me a product of 70. 10 to the second power, or 10 squared, is a 1 with 2 zeros. Again, only if we're talking about a base 10 number, which gives me a product of 700. Ta-da! Here's what I learned. Here's our summation. A whole number times a whole number equals a number larger than what I started with, than my whole number was originally. Case in point, 2 times 2 is 4. 3 times 2 is 6. The number that I get is larger. Now a whole number times a number that is less than 1 equals a number that is smaller, a smaller number than what I started with. 32 times 1/10 is going to equal 3 2/10, because I'm taking a tenth of the number that I started with, only a part of the number that I started with. And we'll get into more of why that is later on in this chapter. Please come to class tomorrow ready and raring with all notes, and enjoy your evening.